Alright, grade 12. We're going to start looking at some transformations here. Today we'll kick off by looking at vertical and horizontal translations. Now we've seen some of this stuff when we've talked about quadratics, radical functions, and some other ones as well. But the interesting thing that we see here is that vertical translations move things up and down. Horizontal translations move things left to right. So we have a function right here. So we'll consider the graph of f of x shown to the right. Now look at the graph below it and see if you can tell what translations have been made on f of x to produce the graph above it and below it. So we have our f of x here, and it's moved up to give us this function here. How much is it moved up? Well, starting point here is at 0, starting point here is at 4, this goes up to about 3, this goes up to about 7. So what do we have to add to 0 to get to 4, and 3 to get to 7? It's 4. So this thing here can be represented as y equals f of x plus 4. Likewise, we can look at the one down below it. If we look at the one down below it, how many units down is it? Well, it's 1, 2, 3, 4, 5, 6, 7 units down below it. Do a similar count here. 1, 2, 3, 4, 5, 6, 7. So it's going to be y equals f of x minus 7. This one right here. Now, when we're moving things, we're only moving them up, down, left, or right. Right now, okay? And right now, we're really just moving things up and down. So, by adding or subtracting a value, we move a graph up or down. The shape stays the same. Okay. So in general, the function y equals f of x plus k shifts the function k units up if k is positive. If k is negative, it shifts the function down. So those are vertical translations. Now, let's look at horizontal translations. We've got a parabola this time. Another one of those functions that you should just know what it looks like. This is a parabola. Y equals x squared by the looks of it. Okay, although that really doesn't matter. Now, let's look at the graph below it and see how the other functions are graphed along with it. So, we've got our f of x, which is this thing right here. This is f of x. And we've got 1 to the left of it, and we have 1 to the right of it. We'll focus in on 1 first. So which one do you want to do first? Let's do the one on the left, just because it comes first if we look at left to right. If we take a look at this one, we have to go back to when we talked about quadratics and even square roots. Because if you remember correctly, the value of the constant inside the brackets for a horizontal translation is always the opposite of what we'd expect. So it goes 1, 2, 3, 4 units to the left. If we were to do that on a number line, we would think, hey, that's subtracting 4. But no, it's actually adding 4 because it's the opposite. So A is plus 4. So this right here would be y equals f of x plus 4. The plus 4 goes inside the bracket for a horizontal translation. Now, if we go, I don't know, I need a different color here. How about we go green? If we go to the right, take a look at the one on the right. How many units to the right do we have to move? 1, 2, 3, 4, 5, 6 units to the right. We have to move 6 units to the right. So we think that, hey, that's plus 6. Well, no, it's actually negative 6. So this would be y equals f of x minus 6. And we can summarize that in this box below. In general, the function y equals f of x plus h shifts the function h units left if h is positive. If h is negative, it shifts the function right. Okay? Pretty straightforward. Moving on. Example. Graph the function y equals x and y equals x plus 4 on the same set of axes. Okay, so y equals x. I'm going to cheat. Whenever you're graphing a line, remember to use a straight line. So that means use something that can draw a straight line. So I have a calculator, so I have a book, ruler, you know the drill. There's my y equals x. Masterfully drawn, if I do say so myself. Now if we're going to draw y equals x plus 4, we have to take that and move it in which direction? Up, down, left, or right? Well, technically, we could actually draw it in 2 different ways. We can move it in 2 different directions, believe it or not. But if I think of x as my f of x, then it looks like it's f of x plus 4. So I should be moving this. The most common way of doing this would be moving this up 4 units. So again, I'm going to cheat because I can. And when I cheat, I am going to make this a different color. I cannot hear your opinions. However, I'm going to guess that you are wanting some purple. So now we've got a purple line. And if we're going to move that line up 4 units, that's 1, 2, 3, 4. Just like so. And I can even it out like this if I wish. And ta-da! There it is. And I guess I should probably draw that graph too. And I guess, I don't know, I'm going to have to find some purple here. There we go. Oopsies. I really don't want an arrow thinger. Good. So now this is y equals x plus 4. Now, how many units lower is y equals, how many units higher is y equals x plus 4 than y equals x? In other words, how much further up is it? Well, 1, 2, 3, 4. It's 4 units up. And that shouldn't be a surprise since it's plus 4 right here. Right? So it's 4 units. The next question asks us, how many units lower is y equals x minus 6 than y equals x? And there is room to graph both of those functions. So here I go. Here's y equals x. Chunk. And I'll clone it. What color do we want now? My favorite color in the world is orange. So we're going to go orange. And we're going to take that orange line and we're going to move it. How many units in which direction? Down 6, you say? And there we are. And I guess I could adjust this a wee bit because I don't need it to be quite as long. And there we go. So anytime you have more than one graph, you should definitely label them both, so you can tell which one is which. So there we go. And the question is, how many units lower is y equals x minus 6 than y equals x? Uh-oh. Tough question here. 1, 2, 3, 4, 5, 6. So it's 6 units lower. Okay? If you have any questions with the stuff, see you this afternoon. Next. No, we have anything else on this page? Nope. Next page. The graph of f of x is given to the right. Draw the graph of f of x plus 2 on the grid below. Well, isn't this just a nasty thing? Because I might actually have to do this time. Well, that's okay. So, what do we got here? I'm going to go draw the original here. There's a point at negative 6, 4. There is a point at negative 2, 0. Rather, my bad, negative 2, negative 2. There is a point at 2, 4. We intersect just like right about here. And then we got a point 6 and negative 2. So what we have is something like 6. Let's go back as far as 8, now it just goes to 7. Okay. So it's something like, gotta try and just get in the moment here. We're gonna draw a graph. And it's not quite, ooh, it's actually right up here. Nice, 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 nice. And then it's right, now where's that? It's just past 4, so it's probably like right about here. And then it goes to 7, right? It goes to 7 and makes a wee bit of a recovery and ends up like right there. Not perfect, but pretty darn close. Okay, there's our graph of f of x, okay? Now, I can still cheat, which is what I was hoping for. But I better change this to a different color. And I'm going to change it to, I really like yellow, but yellow doesn't show up nicely. Oh well. Boo. How can you go wrong with this color? Ooh, it doesn't go well with red. It really doesn't go well with red. So, I don't know. Let's call that, blue looks good. Blue's good with every color. We're going to take that. We got the plus 2, so we're moving 2 units to the left. Okay. And there we go. And it's not the same shade as red, blue rather, but this would be f of x plus 2 in blue right here. And there we go. There's a graph of f of x and a graph of f of x plus 2 by just shifting the whole graph over 2 units. And you might ask, okay, well, how did I draw the original graph in red? I just found key points. And I put them on the big graph below. And then smoothly, or at least as smoothly as I could, join the points in a nice smooth curve, and then using the powers that I have, I move the graph 2 spaces to the left. You would have to move each of the key points 2 spaces to the left and draw a nice smooth curve through those points. Okay? Alright. This is a good one. I really like this one. Final example. How about that? What translations can be applied to f of x and the graph below to produce g of x? In other words, how do we go from f of x to g of x? Well, I gotta move in a minimum of 2 directions. So, what's one possible way we can do this? Well, go 1, 2, 3, 4, 5, 6 units to the left. So I'm just going to write this down. This is not the answer. This is my rough work. 6 units to the left, and 1, 2, 3, 4 units down. Now, how do I do that? How do I do that? Well, y equals f of x, and now the left or right would go in here. So if I want to go left, I would put plus 6. And if I want to go down, I would put minus 4. So y equals f of x plus 6, in brackets, minus 4. Those are the translations that we would use on f of x to give us g of x. Okay. Now, this stuff is only 1 day, so we're not going to have the work period. We're not going to have the hybrid quiz. I expect that you're ready to roll and do a quiz on this tomorrow. We're going to move on and talk about reflections. So your homework is questions 10 to 13, the odds 1 to 29, 32 to 36, ACE, 37, 39, 40, 41, and 44. Quiz tomorrow. I'll see you this afternoon.